This is section 3.4, sum and difference identities for sine and tangent. On this slide, you're going to be looking at some formulas. Here's the first set of formulas, the sum and difference identity for sine. In class, I'll talk to you about where these formulas, or how you can remember these formulas. The next one, or the next ones, are the sum and difference identities for identity for tangent. And then in class, I'll show you where these formulas come from. So here's number one. It says use the appropriate identities to find the exact value of each expression. So we need to compute sine of 11 pi over 12. I am going notice that we're not going to be able to find this on the unit circle, so we change this to degrees. And then at this point, I am going to rewrite 165 as the sum of two angles. So 120 plus 45, and again, these two angles do come from the unit circle. So this is the formula we're going to be applying, the sum identity for sine. This is what we get once we apply the formula. We simplify this expression using the unit circle, and you should feel comfortable doing that. We simplify a little bit more. One more time, and this is your answer to number one. Let's go to number two. So now we need to simplify tangent of 7 pi over 12. Again, this is a radian measure that is not found in the unit circle. First, we change it to degrees, and we get 105. At this point, one of the things that we can do, we can rewrite 105 as 60 plus 45. Then we apply this sum identity for tangent. So this is what the expression that we get once we apply the formula. We apply the unit circle to simplify tangent of 60 and so forth. We get radical 3 plus 1 over 1 minus radical 3 times 1. We simplify the denominator, and we end up with that expression. We rationalize the denominator. So we multiply top and bottom by the conjugate of the denominator. And then we FOIL. This is what we get. At this point, we simplify more. One more time, we divide negative 2 into both of the terms in the numerator, and we end up with the following. The answer could also be expressed the following way. Both of these are correct. Let's go to the next slide. So here's number 3. It says simplify each expression by using the appropriate identities. No calc. So we're going to be applying this identity on problem number 3. Notice that this is going to be like your alpha, beta, alpha, beta. So once I apply this formula, this is what I get. Sine of negative pi over 6 plus negative pi over 3. One of the things that you can do is you can work with the radians, or we can rewrite those as degrees, and you should recognize that it becomes the following. A little bit easier. Then we add these two angles. We end up with negative 90. I simplify this using the unit circle, and I get negative 1. Number 4, I'll go over in class. Let's jump to number 5. So here's number 5, same directions as number 4. Before I start using the identities, I am going to work with the angles. Notice that this is the same thing as 90 minus 60, and this is negative 30. This is just 60, and then this is 90 minus 30, and this is what I get once I rewrite those radian measures as angle, and I simplify. So from here, I am going to be working with the cofunction identities. I'm going to rewrite cotangent of 30 as tangent of 60. So this is what I get. I know that tangent of negative 30 is an odd. Since tangent is an odd function, I can rewrite that as negative tangent of 30 degrees. There it is. Bring over this just the way it is. And now though the cotangent of 60, using the cofunction identities, is tangent of 30. So from here, I am going to be applying the difference identity for tangent. And so I have the left side here, and I'm going to rewrite it as the right hand side here. So this is what I get. Tangent of 60 minus 30, and once I simplify this, I get tangent of 30. Using the unit circle, you should be able to follow that it becomes radical 3 over 3. We're skipping number 6. Let's jump to number 7. So here's number 7. We need to verify this identity. We're going to be working with the left-hand side. We can express 2 beta as beta plus beta. From here, we use this identity, the sum identity for sine. Since it is the same angle. Once I apply the identity, this is what I get. And notice that sine of beta cosine of beta plus cosine beta sine of beta is the same thing as 2 sine beta cosine beta, which is equal to the right hand side. We're done with 7. Let's move on to number 8. We are going to be working with the right hand side, and I want you to notice that the numerator is the difference of perfect squares along with the denominator. So once I factor the numerator and the denominator, this is what I get. From here, I am going to rewrite this as the product of 2 ratios, and notice that we get the same thing. At this point, if you focus on the left hand side, let me change the color. This, once you apply this formula, the sum identity for tangent, so you have the right hand side, you know, is going to have to equal the left hand side. But since we're working with S and T, so it becomes tangent of S plus T. And then on the right hand side, notice that we can apply this other formula, the difference identity for tangent. Once I apply it, this is what I get, and the right hand side is equal to the left hand side. Let's move on to number 9. This one is going to be challenging. It's kind of long, but it's doable, so just follow along. We're going to be working with the left hand side. What we're going to be doing is we're going to be multiplying the left hand side times this, which is sort of like the conjugate of the numerator. So once I do that, before I actually multiply, I am going to expand this expression and this expression using the formulas that you have seen on this section. And this is what I get. I don't do anything with the denominator. I just leave it alone. So once I have this, I am going to multiply these 2 binomials, which means that I have to FOIL. Once I do that, the middle terms go away, and then this is what I get. Now from here, I have to do a little trick and basically look at the right hand side. And notice that I have a sine of x and sine of y. So which means that I am going to make these 2 expressions disappear. And again, look at this sine of x, sine of x, sine of y, sine of y, sine of y. So how do I make these disappear? So I'm going to rewrite those using the Pythagorean identities. And this is what I get. From here, I'm just going to apply a little bit of, I'm going to apply the distributed property. And this is what I get. And the reason why I did that, you're going to see that in just a bit. Notice that this and this cancel out. And all you're left with is sine square x minus sine square y. That's why we did this. From here, I notice that this is the difference of perfect squares. So I'm going to factor that. This is what I get. And once you look at the numerator and the denominator, you should be able to spot that these 2 cancel out, and you're left with the following, which is equal to the right hand side. This concludes video 3.4.